Let's dive right into square roots. So this is some key information that'll help with this video. So I am assuming that you are familiar with like 2 to the second power and 4 to the second power, or any number to the second power. We would also say 2 squared. Just like if there was a 3 here, we would say 2 cubed. And this notation is also common if you're like finding area of a rectangle. So 4 to the second power can also be looked at as 4 squared. So this concept is something that you should keep in mind while learning square roots. Another concept to keep in mind is multiplication and division. 3 times 4, and we know that that gives us 12. 12 divided by 4 gives us 3. So in a way, you can almost see like a relation between these two operations. There's some kind of pattern here, right? So it's the same thing with square roots and exponents. So if we have a square root, and this is what a square root looks like. If we have a square root of some number, let's say 81, you would ask yourself out loud, what number, this is just some random number that we don't know yet, that we want to know, what number squared, or to the second power, equals 81. That would be 9 squared equals 81. So the square root of 81 is 9. So this right here is our answer for square roots. Let's do the square root of 16. So let's ask ourselves out loud, what number squared gives us 16? Or what number to the second power gives us 16? Well, 4 times 4 is 16, so our answer is 4 to the second power gives us 16. So the square root of 16 is 4. It's going to be that number that you're looking for, that unknown that we don't know. This is the unknown. And that's also our answer, whatever number that is. All right, let's do another practice problem. Let's do the square root of 25. So what number to the second power is going to give me 25? That would be 5. So the square root of 25 is 5. Now that we have a basic understanding of square roots, I'd also like to introduce cube roots. I always like to think of square roots having a little 2 here. And this number would be like asking the question, what number squared? So then you're probably going to come across cube roots, which look something like this, where there's a 3 there. Or you might even have ones with a different number, like a 5 right here. But we're only going to look at 3 for now. Because if you can understand a square root, which is this, and if you can understand a cube root, which is this, then you're solid for any other crazy numbers you might find in there, in that little corner, or nook as I like to call it. Alright, so if you see a cube root, this is the same thing as asking what number to the third power this time. So it's not to the second power, but to the third power equals whatever is inside here. So let's do 8. And the goal is to find what this number is. But it has to be raised to the third power. So I know that 2 times 2 is 4, and 4 times 2 is 8. So 2 to the third power equals 8. So the cube root of 8, which is what we're doing over here, is 2. This number, the number that we find, is our answer. Now that you have some understanding of a square root and a cube root, which this is the same thing as just a regular square root right there, and then a cube root will always have this 3 right here. So now that you have that down, what could you imagine this to be? Or how would you go about tackling this kind of problem? There's a 4 here, so essentially we're asking what number to the fourth power gives us 16. We know that 2 to the third power gives us 8. So 2 to the fourth power gives us 16. So our answer is 2. What if I wanted to simplify this fraction? Well, because we did it earlier, I know that the square root of 81 is 9. So simplifying this fraction gives me this. Also, this video serves as a good introduction into variables, right? Because in algebra, you often see x's and y's and m's and b's and these letters, right? This is when letters start to get introduced. And they start to get introduced because we begin to ask questions about things that we don't know, just like this number right here. So what I could have said was, let this random number equal x. It's just saying, like, I'm just replacing it with x. I don't know what x is. I could ask myself, solve this problem. X to the third power equals 8. And by solving this problem, which I get x equals 2, is solving my question here, which there's supposed to be a 3 right here. But yeah. So that's a nice little introduction to variables, and I'll also be going over exponent rules and PEMDAS, which is like order of operations, and yeah. As always, I'll leave some example problems at the end of the video.